morning, my dear students. Welcome to yet another video on the normal distribution part 2. If you remember, in the last video we have discussed about the normal distribution and its basic theories. Today we will discuss some more advanced features and then we will gradually approach for the solutions of some questions related to your various examinations. So just to revise, the graph of normal distribution is called the normal curve. It is bell-shaped and symmetrical about mean mu, and the two tails, left hand tails and the right hand tails of the curve extend to plus infinity and minus infinity towards the positive and negative direction of the x-axis, and it gradually approaches to the x-axis without ever meeting it, right? And here you can see that two different symbols are available. One is z and one is x. You need not to worry about this many things at this point of time. And here we have already discussed that mean will be in between. This is what the mean. You may be wonder that why the mean is on 0, right? Similarly, why z is greater than x and what is capital P. So you need not to worry on all this. We'll cover all this topic in this video itself. Before going on that thing, let's discuss some basic properties of the normal distribution. Probability density function of the normal distribution is already been discussed with you guys, as you can see that f of x, which was defined in the last video also, is equals to 1 upon sigma square root of 2 pi e to the power minus half x minus mu upon sigma whole square. So first property is what, that f of x should be greater than or equal to 0. That means the probability should not be less than 0, or probability could not be negative. Second probability is what, that integration of minus infinity to plus infinity f of x dx equals to 1. If you remember, we have discussed this thing also in our previous video, and this is nothing but sum of all the probabilities should be equals to 1. So that story is there. For the discrete random variable we are adding the probabilities, and for the continuous random variable we are just integrating it because we have the function f of x, right? Now third distribution property is what, the normal distribution is symmetrical about the mean. We have already discussed that suppose this is what a kind of graph for the normal distribution. So we have seen that whatever the things here, the same will lie this side also. That means if we can say that the sum of all this is equals to 1, that means area of this particular side is equal to 1, then this side is 0.5 and this side is also 0.5. We have already discussed this thing. So it is symmetrical about this middle point, and this middle point can be taken as mu as well. So symmetrical about mean. The fourth one, very important property, is a unimodal distribution. It's a unique kind of distribution where you could find mean, mode and median coincides on each other, right? So moving to the next one, let me elaborate you that why minus infinity plus infinity f of x dx equals to 1. Many times we have discussed about this thing, and in the last video only I have committed to prove this one. So for the students of mathematics side, you can see how we can say that the sum of all the probabilities are equal to 1 and why this is equals to 1. To prove it, let's have a simplification on it. So minus infinity to plus infinity, what is the value of f of x? So if you remember, f of x is nothing but 1 upon sigma root 2 pi, right? Then e to the power minus half x minus mu upon sigma whole square dx, alright? To prove this one, we the mathematics student always understand that something which is looking unusual, we put it equals to some transformation. So we substitute, that means integration by substitution method says that if you can put x minus mu upon sigma equals to, let's say, z, right? So in that way, we can find out the value of x is equals to sigma z plus mu. Yes or no? Yes. So in that way, if you can find dx, so dx is what? So dx is sigma dz. Is this clear to everybody? And after substitution, we also have to worry about the limits, as it is a definite integral question. So at, you can see that mu is some constant, right? And at x equals to minus infinity, you can find z is also minus infinity, right? If you can put minus infinity this side, you will find that whatever the value of sigma and mu doesn't matter, z will also move to the minus infinity. And similarly, while putting for x equals to plus infinity, you can easily verify that z equals to plus infinity, right? So there is no change in the limit. I am substituting all this here in the integration, so limits will be same as minus infinity plus infinity. 1 upon sigma root 2 pi e to the power, what was this? X minus mu upon sigma is all z. So you can see that here x minus mu upon sigma whole square was there. This will be what? Minus z square by 2 dz. And one thing is missing, that is dx. So dx we have to replace with sigma dz. So sigma was missing, right? This sigma and this sigma, you can see that can be strike out. It's all easily cancelled, you know. And then what is remaining? So can we take this 1 upon square root of 2 pi, it is free from the z and all outside of this integration. So it is minus infinity to plus infinity e to the power minus z square by 2 dz. Is it clear? And now can we have some conclusion? No, not right now. So how we'll solve it again? So let's think about another substitution, that is put z square by 2 equals to, say, capital T, right? So if we are putting z square by 2 equals to capital T, can you imagine that what will be the value of z? So z square equals to 2t. In that way you will find z equals to square root of 2t, right? And in that way you can find out the value of dz also. So the value of dz you can find out from here. Dz will what? So dz, you can integrate this one also, or you can integrate this one also. So I am using the integration for this one, first one. So 2z dz equals to d capital T, and in that way you can find out the value of dz. Yeah, also one this divided by 2, you know, so this 2 got cancelled. So we have dz equals to dt upon 2. Alright, then dz equals to dt upon capital Z, it's not 2, right? And now similarly you can think about the limits. When you put x equals to minus infinity, you will find t equals to infinity, and similarly if you put x equal to plus infinity, you will find t equals to plus infinity. So putting all this here will give us what? 1 upon square root of 2 pi minus infinity to plus infinity. Then this will be what? E to the power minus t and dt by z, right? And before doing this thing also, let's think about one more situation, that is what? This function is an even function. So can we simplify this one using the properties of the definite integral? And that says what? So that says that if minus infinity to plus infinity or minus a to plus a is the limit, this can be written as 1 upon square root of 2 pi then 2 times integration 0 to infinity, right, and e to the power minus z square by 2 dz. Is this clear? So now what we'll do, we'll apply the values of z square by 2 t here only, not in the previous step. So this could be what? This could be 0 to infinity, right? So 0 to infinity, let me erase this one for you for better understanding. So this limit will be 0 to infinity now, right? And one part you can see that is what? dt e to the power minus capital T is also there, and another part is what? Z, which is looking little unusual. So can we replace the value of z equals to square root of 2t from here? So here you will find 1 upon square root of 2t, right? And also this 2 is there, so 2 times this 2 was missing, right? And integration 0 to infinity, right, e to the power minus t, then dt upon what was the value of z? So value of z was square root of 2 square root of t. Can we write like this, square root of 2t like this? Okay, then you can see that this 2, this is square root of 2, and this is square root of 2, this is pi, right, will get adjusted. So finally here what we can see that what are the remaining, I am writing here just to save the space. So you can see that this is equal to 1 upon square root of pi, right, and integration of 0 to infinity e to the power minus capital T into t to the power minus 1 by 2 dt. Is this clear, my dear student? And this is what? This is nothing but a gamma function. So this can be written as 1 upon square root of pi, and this entire one can be written as gamma half, right? And gamma half, the value of gamma half is what? Root pi. So 1 upon square root of pi into root pi will again get adjusted, and finally we will get 1. So we have started with the integration of f of x dx. That means we have started with the left hand side, and we have just substituted the value of f of x, that means this much, and then integrated it using simple substitution method. And now here only we have used the properties of definite integral, and here only we have used the properties of gamma function, right? And all the things are very simple. Hope you can appreciate and understand this one. Let's have a recap on it. So just to understand the recap, I am erasing this screen on it. So what we did, so we have the value of f of x, whatever is given to us, we have chosen that value, alright. So f of x is this much. Then minus infinity plus infinity, f of x dx equals to minus infinity plus infinity, then 1 upon sigma root 2 pi, then e to the power half. Then what we did, we have put this substitution, and this is said to be normal variate later on, which we'll understand in the coming slides, and then simplified the x equals to mu plus sigma z dx, and everything is obvious now. And after this, what we here did, so after this we have converted this expression into this one, and z square equals to 2t, then simplifying this thing, and dz, that was also clear in the last slide demonstration only. And after that you might have a magic that how this term got like this. So here you can see that this is what? Minus 1 by 2. So can we write minus 1 by 2 is 1 by 2 minus 1? So that was the only thing we have done. That means minus 1 by 2 is nothing but a half minus 1, right? That we have done here. And there is a formula, that is gamma n equals to what? So gamma n equals to 0 to infinity, right, e to the power minus t into t to the power n minus 1. So by comparing here only indication that everything is same, e to the power minus t is there, 0 to infinity is also there, right? E to the power minus t is there, 0 to infinity is also there, t to the power n minus 1. So only change is what? Instead of 1 by 2 we have n. So we can write down gamma n. So substituting n is equals to 1 by 2, we can write down this one as gamma half, right? And gamma half is what? Nothing but a root pi. So this all we have already covered in the special functions, right? If you want to visit the special function, do comment me on that. I will make a video on special function as well. With this you can see that we have successfully proved that the integration of minus infinity to plus infinity f of x dx equals to 1, which shows that sum of all the properties will be equal to 1, and it is a very important property of the normal distribution. Next we will discuss the standard normal jet, that is universal currency. So what happened, every time you might have a different situation, that different values of mu, different values of x, then somebody thought that can we put or can we solve it for e to the power minus z square by 2 by putting x equals to z and mu equals to 0 and sigma equals to 1. How this term came? Let me elaborate here, right? So usual representation is what you have many times we have seen, that x minus mu upon sigma equals to z. At the point mu equals to 0 and sigma equals to 1, you can see that if we put like this, what happened? So x minus mu is what? 0 and sigma is what? 1. So this will be what? Z. So you can see that x is equal to z at this point. So we can replace like this and we can do it. So that's what the kind of universal currency. Need not to worry right now. We will discuss more on it. So why we are doing all this? And that's because of the beauty of the normal distribution curve. So we have already seen that z equals to x minus mu upon sigma every time it is there, and some of the time what happened that when we are choosing now that z equals to x minus mu upon sigma, our usual integration ranges from minus infinity to plus infinity, and every time you need to calculate for f of x dx, and it is equals to 1 because it's about the sum of all the probabilities. But in the normal question or in the practical life question, you will not have the limit like minus infinity plus infinity. You might have the limit from minus 30 to plus 40 or plus 4, minus 30 to minus 70 or whatsoever. That depends upon the situation to situation and question to question. So how you can integrate it and find out the limits from minus 30 to minus 40 or minus 30 to plus 30, that's the question. So what is an idea? So idea was given that anyway when you are integrating the entire normal shape curve, it's all symmetrical about the mean. So this side is 0.5 and this side is 0.5, and in anyway if you are adding all this, that means all this bell shape curve considered to be touching at infinity, you know, it look like a bell. So sum of all this is equals to 1, right? So can we standardize this one? So for the standardization we assume like this. So do remember, my dear student, z equals to x minus mu upon sigma. And what happened? That somebody has calculated all the integral for the standard normal and put them in a table. So we never have to integrate this one. So that's what a kind of story for the standard normal distribution z. And how we'll see the and how we'll compare it. Let me explain you so that you can appreciate well on it. So here you can see that we have now usual representation z equals to x minus mu upon sigma, right? For example, you can see that this is what an x-axis. An x-axis has the two values, x equals to 100 and x equals to 200. So we'll take the different scenarios separately. Also you can see that mu is given to 100 and sigma is 50. That means mu is given to us as 100 and sigma is given to us as 50. Right? Let's substitute all this here. So z will be what? So z is what? 100 here. So 100 minus 50 upon 100, mu is 100, sorry, no? So mu is 100, then 100 minus 100 upon 50. So this will give us z equals to 0. Similarly here z equals to 200, which is the value of x, minus 100, which is the value of mu, divided by 50. So what you will get here? So here you will get z equals to 2, right? 0 upon 50 and here 100 upon 50. So z equals to 0 and z equals to 2 boundaries we got it, right? And now suppose we need to find out the values under this area, that we will discuss in the coming videos. So hope you understand and appreciate that how we find for x equals to 100 this z is 0, and for this x equals to 200 this z is 2. Then there are some properties to understand. Suppose you need to find out the areas the probabilities between the two boundaries of z1 and z2. So in that case you need to understand that how we can find out. So it is nothing but z1 to z2, then f of z dz. So probabilities you can find out like z1 is the lower boundary, z2 is the upper boundary, and f of z dz. Where f of z2 minus f of z1 we have to do. And what is f of z? The f of z is minus infinity to z, then f of z dz equals to b. So that's what the story. And for a kind of calculation, you see, and for the initial calculation, if we have this kind of symbol, we all consider that these all are the same. So how these all are the same, and what are the difference in between? If you can see, mindfully observe, here you can see that less than equal to, less than equal to is there. Here we have one side less than and another side less than equal to. Here vice versa, and here only less than z1 and z2. So we'll assume the same kind of philosophy, and we'll assume all this as equal for the normal distribution calculations and all. Right? Thanks for watching. We'll continue with the use of normal distribution table and all in the coming video.